All right. Well, I think we can go ahead and get started. Welcome, everyone. Today, NARUC will be hosting a Regulators Financial Toolbox webinar focused on leveraging software as a service, cloud computing, and AI and electric utilities and their operations. So for those of you who are not familiar with NARUC or our Center for Partnerships for Innovation, NARUC is a trade association for all 50 state public utility commissions, as well as U.S. territories. NARUC CPI is the technical assistance branch of NARUC, dedicated to providing TA to all NARUC members. And our goal is really to identify emerging challenges and connect state commissions with expertise and strategies to help inform their decision-making. CPI loves to build relationships, develop resources, and deliver trainings, and we're also supported by federally funded cooperative agreements from the U.S. Department of Energy and U.S. National Institute of Standards and Technology. We thank them greatly for their support in making this webinar happen. And there's some more information to the right about some of our recent publications, virtual learning opportunities, and more, much of which you can find more information on our website. And I also want to just briefly touch on our 5 key topic areas that CPI focuses on, which are energy generation with topics like resource adequacy, coal and carbon management, nuclear energy, and energy transmission, whether it be at the bulk power system level, transmission infrastructure, or transmission distribution coordination, energy distribution with topics like DR integration, compensation, microgrids, smart grids, and performance-based regulation, energy customers with topics like virtual power plants, electric vehicles, which I focus most of my time with, as well as environmental energy justice and affordability. We also have a team that focuses on critical infrastructure preparedness, response, and resilience, looking at topics like cybersecurity, emergency preparedness, and integrated system resilience. And you can contact Kira Zeidelman, Deborah Reynolds, if you're interested in energy generation and transmission, Jeffrey Loiter, who's on the call here today, or even myself, if you want to talk more about energy distribution and energy customers topics, and Lynn Constantini for anything related to infrastructure, preparedness, response, and resilience. And I'd be happy to get you in touch with these folks if you're not familiar with them. I can get to the next slide. There we go. All right, well, we're really excited about today's panel. NARUC has been interested in this topic because of concerns raised over issues like cost recovery, the fact that it's a rapidly changing need for utility IT systems, including the ability to be flexible and interoperable with each other, as well as just the general potential for AI to provide value to utility operations across the value stack. So without further ado, we'll go ahead and get started. I will hand it off to our moderator today, the Honorable Chair Bartlett from the Maine Public Utilities Commission. Chair, I will hand it over to you.
Great, thanks so much. It's a pleasure to be with all of you today. I feel like when we talk about sort of these technologies, and particularly AI these days, it's all in the context of all of the new data centers that are being built and the challenges that that pose to the grid. So I'm glad today we have a chance to step back and take a look at software as a service, cloud computing, and AI from the perspective of what benefits can they bring to our utilities and to the grids that we're trying to manage or we're requiring more and more flexibility from, as well as dig into some of the challenges, including privacy concerns and getting into like cost recovery. How do we allocate these costs fairly and think about how do we really think about the benefits they're providing to our distribution and transmission systems. So with that, I'd like to sort of get right into it. We have 2 great panelists. We have Emma Rodvien from Kraken. She's the manager of U.S. Regulatory Affairs and Market Development. And we also have from Itron, Mimi Zhang, who's the Director of Product Management, and Andrew Cook, who's a Group Product Manager. So we'll kick it off. I'll toss it over to you, Emma, and we'll have presentations from our panelists, and then we'll have hopefully a lively Q&A at the end.
Thank you so much, Chair Bartlett, and thank you to NARUC for pulling this session together. My name is Emma Rodvien, and as the chair mentioned, I'm coming to you from Kraken Technologies. Kraken is the software licensing arm of the Octopus Energy Group, which some of you may have heard of. We have businesses in retail energy supply, customer products, and then, of course, a software licensing arm. So we can advance to the next slide, and I thought, before diving into all of those rich subject topics that the chair mentioned, it might be helpful to orient ourselves, sort of status update. Where is the status of these conversations around SaaS today, particularly given the uniqueness that NARUC convened this sort of session topic 5 years ago. I thought it would be fun to think about what has changed since then, both in the SaaS industry and in the utility industry, that sort of brings us to where we're going to initiate today's conversation. And so, of course, there have been tremendous evolutions in the last 5 years since NARUC's financial toolbox on SaaS within the vendor industry itself, new functionalities, new use cases, whole new types of risk mitigation strategies being brought to market, and of course, new commercial models and pricing structures that we're seeing work within the oddities of the regulated utility context. And then goes without saying for this audience, tremendous evolution as well on the utility side at the industry as a whole, but also specifically within utility IT organizations. There's a couple fun bullets here. I thought I'd call out a few that I think really ground the conversation. This one sounds quite practical and small potatoes, but it's really meaningful. Many seasoned IT staff at utilities are retiring out of the workforce. And especially when we think about core IT legacy infrastructure like ERPs, financial record systems, billing systems, many of these systems are decades old and were built with really customized, specialized programming languages and knowledge. And so as the staff ages out and retires, a lot of what we're hearing from utilities is, oh my goodness, how are we going to maintain the legacy infrastructure that we have? There is a tremendous inflow of data coming into utilities these days that doesn't need much description. I'm sure we're all familiar, whether it's meter data, grid level data, customer information. There's just, an onslaught of this information. And naturally, the question becomes, how are utilities going to make use of that data? With what tools, what functionalities, and capabilities do they need for that? And then, of course, at the backdrop of all of this are the emergence of new regulatory requirements, driven by the energy transition. So requirements for new products and new services and wholly new ways of doing business at the utility level. And what I think is unique about today versus where we were 5 years ago is the conversation in those earlier years was maybe around pilots and how do we get this to work at an initial level. And now what we're seeing is utilities are really scaling up to full scale these new innovative offerings. So whether that's moving from like a time of use pilot to a default opt-out structure, that's a rate design example. You can imagine many other iterations of this. It puts new strains on the IT organization and the allocation of tools and software for that. So we can go on to the next slide. Before getting into the applied content here, I wanted to give a brief, slightly deeper introduction to what Kraken does in this space and highlight the one particular use case that I'm going to be talking about here. So Kraken licenses really 4 primary software types to energy utilities. We have that software ranging from the sort of grid edge to the internal customer operations. And for today, I'm really going to focus on our customer software, which you see here in the top left corner of the screen. This is our flagship sort of cornerstone product, and it comes as a pre-integrated billing system, meter data management system, and customer relationship management system. So that does everything from engaging the customer experience, customer interface with the utility, up through pulling and managing meter data into a billing system to be able to transact products and services between the utility and their clients. What we think is so special about our approach to this product is that oftentimes utilities in the past have procured these IT tools independently of each other. So they'll go to one vendor for a billing system, a different vendor for an MDM, maybe a different vendor for a CRM. And what that means is that each of these products was designed with different criteria, maybe coded in different languages, has very different features and parameters to them. And they had to find a way as the utility, as the client, to stitch them together and make them work well together. At Kraken, we sort of flipped that logic on its head and said, all of these pieces need to be coming from the same starting point. They need to speak the same language, so to speak. So we've designed them from a single data model so that making change to one easily flows through to other to really help utilities kickstart and jumpstart their customer organizations. Next slide, please. What you'll see here is just a high-level overview of where Kraken is with this technology right now in the field with deployments. We have licensed the Kraken customer solution to over 40 different clients throughout the world. And currently there's upwards of 60 million customer accounts that are hosted on the platform. So that means accounts that are being billed through Kraken, where the customer communication is happening through Kraken and the data storage is happening on Kraken. Something I wanted to highlight here that speaks to the sort of technical design of our solution, which is a SaaS-based billing system and customer IT tool, is that we take a very common approach in the SaaS world to our product design, and that's CI/CD, continuous improvement, continuous deployment, continuous integration rather. And so this is a model under which we're constantly pushing updates out into the production field. So we have 200 or so on average daily deployments, meaning daily code changes that are going live and being pushed into production. Many of those are very, very small things. For example, maybe just a change to a font of some part of the user experience. But some of those updates are larger client-driven changes. So maybe a brand new functionality that a client needs to keep pace with an evolving business need, or a new rate design that's going into effect in the billing system. Those are obviously larger changes, but they follow the same deployment pattern. And what the CI/CD model allows us to do is run a really tight deployment and testing model, which ultimately increases our speed to push from production into a use environment for our clients. And it's that speed and agility that following a SaaS model for our billing product really allows us to differentiate ourselves on. Next slide. So we're talking about the use cases for SaaS today, and you're going to hear from Itron about a different use case in the metering space. But today, I really want to lean into sort of the nexus of customer IT and billing with SaaS. Where is the point of overlap? What is the benefit that SaaS can bring to that one particular use case? And the genesis for our company, why we even got into the customer IT space to begin with, is that we surveyed the industry across the globe, not just in the US, and saw that across the board, billing systems are really emerging as a bottleneck to the energy transition. When we think about all of the advancements towards decarbonization, towards market efficiency, towards integrating new technologies onto the system and managing a much more dynamic power flow, really we're talking about, needing to equip our utilities with better tools to precisely manage supply and demand. And, from a basic market economics perspective, the price signal and the way that pricing of these products and services happens is traditionally the way that, market participants have to organize themselves. And so it's no surprise that commissions are seeking and pushing towards rate design innovation as that core tool to organize both the supply side of the market and the demand side of the market. But in reality, as we've taken collectively steps towards rate design innovation and product innovation, the billing system has slowed that down along the way for many utilities today. Right now, most of the billing system and customer IT landscape is served by aging on-prem solutions. So these are software packages that were developed by vendors and hosted on, local equipment at the utility, hardware at the utility. And the reality is they're reaching end of life. And so we're at a very interesting moment in this space where many of the utilities across the country are thinking about replatforming to a new system, buying a new system simply because their legacy infrastructure is at end of life. And because these are such long life systems, getting this procurement decision right over the next couple of years is a really critical moment for utilities and their regulators, because it only comes around every once in a couple decades. And so that's why our company is really focused on bringing this messaging both to clients, to stakeholders, to regulators, that, you know, this is a really important time in IT procurement to make sure that the solutions being put in place will not only serve today, but serve all the type of innovation that we all collectively want to see happening in the future. The reason why we think a SaaS model is really well fit for the customer IT and billing use case comes down to two sort of unique benefits of SaaS relative to the traditional on-prem software model. And that is related to the pace and the cost of implementing change, as well as what that sort of faster and cheaper cost will allow in terms of product design and iteration for the client. So if they can put changes into place faster and be able to iterate with product and program designs on top of that change, it's our philosophy that what comes out of that is a really de-risked approach to product and pricing innovation. If a utility doesn't need to spend $6 million to try one new rate design, and that takes 12 months to code up, maybe that means they can iterate a little bit more, put something into production, try, say that didn't work, we'll move on to phase 2. This is sort of bringing that innovation mindset into a part of the utility IT universe that typically has not experienced that benefit. Next slide. So naturally, the question as a vendor becomes, okay, we think our product has all these benefits. We think the SaaS model relative to the traditional on-prem model itself has all these benefits in this use case. How do we get it to market? And how do we help our clients, who are regulated utilities, make ultimately a regulatory case for this product? So at a theoretical level, our thinking is really that our product needs to be able to compete on price, meaning it has to cost less than its alternatives. It has to deliver more benefits or different types of benefits from the traditional on-prem models. And we have to have a different risk profile. And what's important is it's not just a technical risk profile that we're thinking about, but really a commercial risk profile. I'll get to this here in a minute, but one of the things that allows SaaS to be so different and compete on value is the way that we price our products, where we're not just offering a static piece of code, a static set of functionalities. We're allowing iterative changes, new functionalities, new features to be built on top, and have a commercial model that really appropriately shares the risk of the cost of that change between the client and the vendor in a way that the traditional on-prem model doesn't. So as a vendor, again, we seek to be able to compete on each of these three cases when we're working with clients. It's not to say that every time we're meeting each of these criteria, but this is our goal in thinking, how do we get this solution into an industry and into a use case where it really hasn't been present to date? Next slide. So taking it out of the theory and into actuality, I wanted to present just a quick couple examples of how Kraken is doing this, what makes our billing software as a SaaS product unique and beneficial in this particular use case. So the first item here relates to just the speed and the cost of how we support billing changes on behalf of our clients. I'm sure many of you have experienced that dynamic I spoke about. You want to change something in the billing system, it's 12 months and a couple $1 million. In contrast to that, I've displayed here a couple different types of client requests for new functionalities or features in the billing system, and how long it's taken Kraken to implement and deliver those functions for the client. So the important thing here is that you're seeing order of magnitudes of weeks to months. Typically with standard systems, you're talking about months to years. And so that massive change in speed is a big driver of benefit for our clients. And it's not just speed, it's the cost of delivering those changes. So unlike those traditional models where a singular version of software is purchased, and yes, there is a long tail of maintenance to make sure that version is maintained, incremental change, new functions, new features are completely separate. We bake in those new functions and features to our pricing model. So it's really our belief that we're here through the SaaS model to help the client keep up with its regulatory changing needs and its business changing needs, and to price that into our annual service fees. Most of those times the service fees are fixed over time. In some cases, they might fluctuate year to year, but all of that is agreed to upfront with the client. And so there is an element of price predictability that comes really useful when you're talking about a utility that's having to carefully budget for so many different competing priorities at this point. Next slide. Another feature that makes our billing SaaS product quite unique is our approach to the actual migration from old systems onto our new system. So it's not surprising that getting off of a legacy billing system and onto a brand new platform can cause a lot of heartburn for our prospective clients when we talk to them. We've done it now dozens of different times, and we've built a really unique model to this migration that is specifically designed to take as much as possible the risk out of this transition. And the way that we approach this is through a philosophy called BOT, Build, Operate, Transfer. And graphically, it can be depicted in terms of an S-curve. So whereas traditional migration models follow a big bang pattern where the client and their vendor and a system integrator for years work to build and perfect this new piece of software that's going to do everything it needs to do, testing, refining, and then when it's perfectly ready to go, cutting everyone over from the old system to the new, we flip that logic on its head and we break out the customer base, our client's customer base, into tiny cohorts, so subpopulations that fall into lines along sort of functional lines or needs-based lines. And we build a sequence where we move sort of the easiest customers over to the platform first, which allows us to build sort of a minimum viable product and then continuously build more and more sophisticated functionality on top of that while moving customers over consistent with that functionality, such that by the end, all customers are moved over, the full functionality is deployed, and the client can retire their existing system. Next slide. The value here really is in obviously a mitigation of technical risk. So when you have a big bang cutover, the risk is that one piece of that system that you're transferring onto doesn't work, and it creates cascading effects that create deficiencies and failure points that require months and months of time to mitigate and fix. That's the technical, risk that we've attempted to mitigate through this S-curve approach. But there's also a less sort of understood commercial risk to that approach, which is that if you're building a product to spec over multiple years and then cutting over immediately, that makes it very vulnerable to change that happens in the building period, in the implementation period. And we understand life doesn't stop just because there's a software migration happening. And so to make this point, I think this is a really illustrative example here to show exactly what this commercial risk is under the traditional software model. There was a utility in New York that just completed a recent billing implementation replatforming project. It took 4 years to move from a legacy system onto a new on-prem billing software system. And over the course of those 4 years, tons of new regulatory changes came down from the commission that required the new ways of using the billing system. And so during migration, not post-migration, but during migration, every time one of those changes came down the line, the recoding and the testing had to pause so that everything could be reconfigured to be consistent with those new requirements. That added labor burden for testing and again, for making sure everything was incrementally where it needed to be. And then by the time that happened, a new change order came down the pike, and this just cascaded and created a huge cost overrun, primarily driven by this ballooning labor cost of keeping up with that incremental change. Now, under the type of migration model that Kraken brings through its SaaS product, that change could have been flexibly handled through our cohorting approach, where we could have staggered work, delayed one cohort to be able to fix, a piece of the code that was touched by one of these change requests. And ideally, what we would like to think is that that cascade of labor required to keep pace with each of those changes would have been significantly lower under our model. Next slide. So now is the point where it's like, I'm saying these are all these benefits where, the SaaS product is so well aligned with the use case, and here's why it's so great. And the reality is, you might be thinking to yourself, but then why don't I see it more, right? Like if it's so great, why is it such a small share of the IT infrastructure, both, for this specific custom use, but also across the board? SaaS still doesn't make up the majority of IT infrastructure. And so from our vendor's perspective, there's really three key challenges that we're facing in the market today, and I've laid them out here. The first is related to cost baselining. So what are we being compared to? What is our system being compared to when a utility goes through a procurement effort? The primary challenge we face here is that, as I mentioned, our business model is to include both initial implementation as well as ongoing upgrades, new features, new functionalities in our pricing model. Under the traditional on-prem alternative, those systems are priced from an upfront implementation perspective, just the cost to get a piece of software and stand it up. And those incremental new features and functionalities to keep pace with the client's evolving needs are completely separate. They're incurred through different budgets, they're priced in different ways. And so it's hard as someone who's baking both of those costs into our product to compare against an alternative where those costs are not always incurred in the same place. That data might not even live in the same place. It's a challenge to compete there. The second challenge is related to IT interdependencies. We obviously have a theoretical potential of benefit that our software can deliver, but to deliver that full theoretical potential, there might be interdependencies with other IT systems, staffing requirements, organizational philosophy, and if all of that isn't in place, a smaller set of benefits might be delivered in reality. And that's obviously beyond our control as a vendor, but we live and die by that value profile. And finally, because we're bringing a different suite of benefits to the table when in the billing space in particular, we sometimes bump up against methodological limitations to quantifying the values we bring to the table. When we talk about things like customer experience, ease of customer participation in programs, customer retention, everything relating to how the customer participates with the products and services the utility is selling them. Those are hard things to quantify. Those are hard items to put firm dollars and cents to, yet that's such a big piece of what our value has been to date. And so bringing that to utilities and helping them go through that business case exercise has been challenging. Next slide. So I'll end here and pass the mic, but I did want to just end on a practical note for those of you listening in with some recommendations on how regulators can start ensuring that SaaS alternatives are adequately considered in the utility procurement process. It ranges from low lift items like taking an inventory of where SaaS is being used by your utilities today, what the use cases are and why, all the way up to making sure that your program design, exploratory proceedings, and dockets have a dedicated space to think about IT implementation. So not just what should the design of a new rate be, or what should the features of a new program be, but what is it going to take at the utility to implement that? Where are the functional gaps? What are the capabilities and the staffing needed? And how would that gap be closed when it gets time for implementation? So I'll pause there.
Great, thank you, Emma. And we can now turn it over to Mimi. I think is going to get things started.
Okay, yeah, I'll get things started and then hand it over to my colleague Andrew. I guess next slide. Don't mind. All right, so a little bit about us. Why are we here? I've got a couple slides explaining why Itron is actually here to talk about SaaS, cloud, and AI. But a little bit of history about me. So I work in product management at Itron. My team handles software for kind of smart grid, advanced metering infrastructure. And previously, I actually lived in Boston and worked more on the policy consulting side of things. And then Andrew has a lot of experience in the industry. He covers all of our SaaS analytics platform products. So he spends all his time, working on our SaaS products and talking to our customers about buying and using SaaS as well. And fun facts, his kids are a lot older than mine and are a lot more put together. All right, next slide. Okay, so a little bit about Itron. You guys may be familiar with Itron. You've probably seen an Itron meter at some point. Itron has been around for many decades, selling different types of meters over the evolution of meters, from analog meters to the advanced meter reading, drive-by meters, as well as now a lot of two-way communicating smart meters. We have a lot of endpoints. We're global. We've got offices globally. We also provide network streetlights and a few other solutions. Next slide, please. So why are we here if we sell meters? I wanted to kind of touch on a couple of slides to just really go over Itron. So when we do a smart meter deployment, which is a lot of what, Itron kind of core has been known for, those are part of smart grid advanced metering infrastructure deployments. So in addition to the meters themselves, which are part of a network, there's actually a lot of software and analytics that are needed to kind of go along and support an AMI deployment. And as we've been doing these AMI solutions for utility customers over, let's say, 15 plus years now, naturally a lot of other offerings and capabilities kind of come out of that. And so we'll talk more about kind of the evolution of AMI as well as the business cases and how things have really changed over time. But this is just a list of a bunch of stuff that we've added to the portfolio or grown over time, usually at the request of a bunch of customers kind of wanting to take the next step. And now a lot of these things are actually a pretty core part of an AMI consideration or an AMI program when somebody's looking at doing a new one or doing a refresh of an old legacy system. All right, next slide, please. So here's just another way to look at it more visually. So, going back, say, 40 years, I think when Itron first became a public company, you have all these endpoints and everything had to be manual. So there was really no real-time intelligence, real-time feedback. Some decades ago, we started the automated meter reading functionality where you could drive by. And so it got rid of manual meter reading. That was kind of the start. But I think the real game changer has been the advanced metering infrastructure with the two-way communications where everything's on a network. And then we've seen once the meters are on a network, you can start adding other stuff. You can do a lot more with that data. There's a lot more real-time capabilities coming out of that. All right, next slide, please. So different way to look at sort of the stack. Mainly, I just want to show how much of our solution stack is actually up at the top, really focused on the software. So while a lot of our endpoints and a lot of that revenue number in the earlier slide comes from selling devices, the network itself, I think, is very special. It's very important. What you can do with the meters is only as good as your network and what you can get across the network and how quickly and how good the performance is, right, as well as the reliability. So we have a software suite that helps manage the network, does data reading from the meters, can kind of push commands, sort of all of that core management for the network and the meters. And then on top of that, there are other products at Itron that we kind of integrate internally. There's a meter data management system, as well as a whole bunch of things, up top, you'll see outcomes where Andrew works. And those are a lot of newer software capabilities or primarily software capabilities that we've added, more recently, although some of them have a very long track record. And those have often been added because we're seeing them as demands from the market. We've seen them as demands over time from utilities kind of needing or wanting these capabilities to go hand in hand with the AMI deployment, or some of them are actually becoming part of an AMI deployment when you get up and running. All right, so fast forward a bit. I'll talk a bit more about just AMI business case and the evolution, and then I'll hand it over to Andrew to talk about SaaS and cloud. So if you look at the history of AMI, kind of starting in the late 2000s, even until I would say 5, 6, 7 years ago, they were typically focused on, okay, we're going to put in smart meters to replace manual meter reading. And then there's kind of some basic, outage restoration, some data management. A lot of those were kind of key parts of the business case. Now in the 2020s, we're seeing a lot of different use cases coming up as part of kind of requests and benefits that need to be shown as part of an AMI business case. That's really exciting. So this means that we are kind of doing more investment in our own software, as well as partnering with more companies in the ecosystem as well. And what's even more exciting is we're seeing a lot of customers also, building their own apps and building their own offerings. And we're trying to kind of help support that as well with different platforms where they can actually build apps and share and sell what they've built with other utilities. Go to the next slide. So I've got a couple around just kind of business case trends. So kind of similar to the previous one, if you just look on the left, kind of, think about this as just a really old school, classic AMI business case from the beginning. Maybe we weren't really sure if this was worth it, right? When we looked at the first few. Of course, we've learned since then that there are so many things you can do, kind of, especially building on top of that infrastructure. If you're looking at just the core infrastructure itself, kind of the avoided meter reading, avoided truck rolls, outage restoration, right? That might get you kind of close to break even. Then once you start adding in things like distribution automation or conservation service voltage reduction, that can really help make the business case positive, and that's without needing to rely on any other energy efficiency or consumer related changes. Then when you go in and start looking at demand response, energy efficiency, and other applications, not even new ones, things that have been around for a while, you really start to see that benefit cost ratio kind of go up even further. And looking at some of the customers that we've had for AMI deployments, we've had quite a few actually end up over kind of the 2-to-1 benefit cost ratio, which is really good to see. Let's go to the next slide. So now talking a bit more about software and how it kind of fits into the AMI business case conversation. A lot of it is around infrastructure. It's pretty clear, where the meters fall when you're looking at CapEx, OpEx, right? What goes into a rate case. Okay, meters, obviously, devices, maintenance, warranty, things like that. I think even a perpetual software license is pretty clearly considered kind of a capital expense because it's a big upfront expense. And if you buy a perpetual license, you own the thing forever. And as Emma was saying, things have really changed with SaaS. And even we're seeing that too. A lot of our products have moved to a SaaS model, or we would like to move it to a SaaS model because we also like to be able to kind of, keep making improvements and, not having to treat every change and every version, right, as kind of a new product. We know that for customers with AMI, their core software system needs to keep evolving and kind of keeping up with the times. Even if they bought a perpetual license up front, we're still introducing fixes and improvements and wanting them to take upgrades regularly, just to keep up with security changes and just keep up with the times. And so a lot of our new deals are, initially being looked at as SaaS, where Itron actually handles the hosting for the utility customer so that they don't have to spend a bunch of time doing data center infrastructure management work. But we have seen, sometimes they do have to come back and say, well, we really need to just buy the license and figure it out ourselves because we just can't afford, right? We couldn't figure out a way to do the accounting so that this can be CapEx, and we just can't afford to take it all out of our operating budget. And so we've done a few things to try to help with that, where we sometimes will separate out the license from the hosting so that they can still purchase hosting from us and still sort of buy the license and capitalize it. It's still not ideal though, because, with SaaS, like you kind of put everything in and I think Andrew will talk about this more, but once, if you can sell something as SaaS, it's a lot clearer to the vendor kind of what your revenue and growth is. And it's a lot easier for us to actually make these investments in the product over time. If we're splitting things out between kind of a perpetual license and hosting, that license comes in kind of upfront one time. The hosting is ongoing, but if we're looking at innovations for the product, it's certainly more helpful for the vendor to kind of just see a steady growth over time instead of sort of lumpy revenue coming in. But I understand it's tough because if you're looking at sort of your AMI deal and what the costs are for a utility customer, right? The cost, there's kind of vendor, there's kind of the cost of what you pay to the vendor between devices, right? Buying the hardware, buying the licenses, paying maintenance. There's always a lot of integration, install, training, right? Typically a system integrator is involved for something like an AMI deployment. There's also a ton of internal costs, especially if you're doing it for the first time. You got to do testing of all the hardware, vet it. All the installation, deployment, changing your operations, staff training. I mean, it's a huge change for operations at a utility, especially the first time around. And then if you're buying a perpetual license and hosting yourself, you've got to deal with all the data center infrastructure and installing it, upgrading over time. And then as Emma was saying, most utilities have products from a whole bunch of different vendors. So now you got yet another vendor in the mix with even more software. So you got to do integrations to everything, and then interoperability testing. You got to manage all the vendors. Anytime one of the vendors, anytime you take an upgrade to a big new version, right, of a vendor software, you either got to do interop testing of everything. What we see is that typically our customers will wait and try to upgrade everything at once. So that's how it takes 4 years, right, to go through all the testing and deal with the changes and retesting. And then for us too, if we introduce a change or we do a fix that's pretty noticeable during a testing period, it really throws a wrench in everything. And it's hard because we want to keep changing and improving, right, our software as continuously as possible. And we understand it's really hard for our customers, especially in a on-prem, in an on-prem world, to kind of accommodate those types of changes. And over here on the right, these are just some kind of cost categories where I just wanted to show with this that, in an on-prem world, it is pretty clear where software falls and how you can capitalize it. I think in a SaaS world, it just becomes harder. And so, we agree with Emma. It's having some more support for that would be really helpful for the overall ecosystem. All right, next slide. We'll talk a little bit more about benefits for AMI. So, as I was saying, there's a bunch of software that is just required for AMI functionality, even your basic meter reading, network management. And then, we're seeing a bunch of other stuff now getting included often with a deal. Something Itron's been doing a lot of is actually working with our utility customers around adding analytics or grid intelligence, and that's been really exciting. We now have a lot of meters that can support kind of edge compute, and so we already have a pretty vibrant ecosystem of distributed intelligence applications. Some of them are made by partners, some of them are made by utilities themselves. We kind of vet them to make sure that everything meets a certain standard. But any entity can really try to make an app and sort of sell it to other utilities for use. And then there's a lot of adjacent software, and we've seen a lot of evolution there, including Kraken's products for billing and a lot of other things. But there's just a lot of other software that every utility needs to use, and some of it's getting consolidated. We do see a trend in things moving to cloud, but I think it's going to be a pretty long road. And right now we are noticing there's still just a lot of cost in adopting new things, doing the updates, right, testing new versions, and then all the integration and interop testing. In terms of benefits for certain software products, I think it can also be challenging to figure out how to pay for it, because there may be a piece of software, if it's not included in a base sort of AMI business case, if you're trying to add something later, it's not always clear who gets the benefit, right? And then if you're looking at paying for it as SaaS, then it's even less clear kind of, can this be capitalized? Is it not? How do I split it up, right? Can I capitalize any of it? But I just wanted to note that sometimes it is just challenging. If there's a product that does a lot of different things, like it may actually benefit, or provide O&M reductions for different organizations within a utility. And so that's where I think it's especially helpful to support utilities and be able to come back and at least try to, get help paying for like a base platform, right, or something like that, especially if the benefits kind of are spread out across the organization. All right, next slide. I'm got two examples from our utility customers of just, utilities that have done smart grid, used software, and seen some benefits from them. ComEd is one I want to mention. I think both of these examples are customers that have had Itron host their AMI software from the very beginning. So they did not go with an on-prem model. They are still faced with the same challenges, though, of having to do a lot of testing and interoperability testing between their back office software, but they at least didn't have to do all the data center management and do the upgrades themselves. But ComEd has a really successful AMI program. The reason this one stands out is that they've actually filed for 5 rate decreases between 2010 and 2020 because the benefits were really coming through. So that's exciting. And I also want to mention they've got a really cool innovation lab where they try out new products. They have a lot of stuff with universities, startup incubators, things like that. And they have a track record of really taking kind of multiple vendor products, adding some of their own stuff to it, and kind of making solutions out of them. So one is an award-winning outage program called Compass that even, I think it's part of their app that customers can have on their phone to help report an outage, ping their meter. It's really cool. And I think they've really been able to leverage a lot of capabilities out of different vendors' products and kind of pull them together. And so I'd love to see more of that over time. And then the next one, if you go to the next slide, is an example of a distributed intelligence platform application. So CenterPoint Energy, a couple of years ago, deployed a bunch of meters with the DI capability. And in just 4 weeks, they were actually able to kind of pilot a DI app. So this is a software platform, and then the apps themselves end up on the endpoints. But kind of everything that manages them is definitely a software kind of Itron hosted platform on the back end. And in just 4 weeks, they were able to put the apps out there and try it out, and saw kind of really good success for this program to really help them make the decision to kind of expand and maybe even try more apps over time. So that's another kind of shout out, I guess, to having something like a SaaS offering. It was just really fast for us to be able to help them get up and going and try something and help them kind of have the data points to make the decision on, does this thing work? Great. Like now we can go forward, or, maybe it doesn't work, but it wasn't like a year-long IT project investment for them to just be able to try it out. All right. So with that, I'll wrap up on AMI business case and hand it over to Andrew to talk about SaaS and cloud.
All right, good afternoon, everyone. Yeah, so we'll talk about kind of SaaS and cloud offerings, or Itron, kind of our perspective on this topic. Go ahead and next slide, please. Sorry. So really, a lot of the benefits that we're seeing with SaaS and cloud, and the benefits we believe we can provide to the customers is one thing, the traditional on-prem software, where whether it's hosted, and I think there's a difference between, I think, hosted software and truly software as a service, where in my view, and this is just Andrew's opinion, software as a service, you're effectively, it's like subscribing to the newspaper, right? You're subscribing to get the news every day. And so all these things have to come together to give you that newspaper and the adequate news every day. And then you can turn it on and turn it off however you want, or decide to get different news. I mean, it gives a lot of flexibility. Whereas, on-prem is really like, I got to buy the newspaper company, to get that benefit. And I think what we've seen a lot with the traditional on-prem software, where it's licensed, it's on-prem, you own the software. But if you have an iPhone, you realize, software lasts maybe a couple of years, or constantly has to improve and tweak. Where it's if you're buying the license, okay, you're expecting that software to last for 15 years and be offered. And we know technology changes so quickly that and then even trying to maintain these legacy systems, and even trying to maintain the expertise needed, to maintain them and keep them moving and vibrant, and providing the capability, over 15 years, I mean, that really, has a lot of challenges to it. Whereas with software as a service, where you're subscribing to a service where the software itself, the vendor is handling everything to deliver that, to specific service level agreements, specific benefits, tracking those benefits with you, handling all the security requirements around it, really just managing and offloading a lot of that headache and resource strain, from the person who bought the on-prem software, to more to the software as a service vendor, to maintain all that. And so I think there's a lot of benefits around that, even just offloading, burden and resources from our customers, into our software as a service offerings. And so that's kind of one really big benefit, I think. I think also and so there's a lot of costs with just maintaining and trying to keep going, an on-prem or traditionally licensed software over its 15-year life. Whereas, and the other component of that is you also have to size your infrastructure for the peak usage. So if you have processes that operate 1% of the time and they take up, 90% of the compute, well, you're buying infrastructure and holding that infrastructure, and maintaining it, and having to operate and build expertise around it for that 1% of usage. Whereas with SaaS and cloud software, we have a lot of that flexible compute. So now we can do things like using containerization and other techniques to say only, okay, run that job for the 10 minutes it needs to be run, fan out the compute, shut it down when it's done. We can automate that whole process to be more efficient with the compute spend itself. So I think that's another kind of cost that we'll see on-prem that we won't see in SaaS, because, and you won't even see it with necessarily hosted software, because they got to do the same thing. Traditionally, software designed to be on-prem that's just hosted, it's got to be sized for the peaks. And then as we build in more of a truly cloud native SaaS software, we see that it can use flexible compute and be more efficient with its resources to lower the costs, as well as provide better resiliency and benefit to the users, as well, whether it's internal user community or external, consumer user community. I think, and part of the benefit of this also is being able to use like Emma talked about, CI/CD. So this continuous delivery, and I think sometimes when people talk about continuous delivery, where I remember when we first started with one of our products, Itron Analytics, we're going to do updates every 3 weeks, and people are like, how will we possibly handle that? That's like just overwhelming. And I think what we've definitely seen here is one, when you do continuous, if your infrastructure is set up so that you can deploy a change at any time, multiple times a day if needed. We've got some products that, do multiple times a day, they'll do changes, and they have that infrastructure all in place. And we do really small changes more frequently. Actually, quality goes up. The training burden goes down, because you're absorbing small changes over time instead of these really big bang fundamental changes and retraining that you have to do for new capabilities. We can roll out things smaller and smaller bites, try them out, do A/B testing with different cohorts, and improve and pivot where we need. And so I think you see a lot of benefits around just even just the training burden and the testing burden, when you employ CI/CD, which is inherently SaaS products, strong ones, are set up that way. And even though you kind of think, well, there's gonna be so many changes, it'll be bug city. The reality is actually the opposite, because you're able to, roll things out in a controlled manner. You're able to try them out with actual users and actual production environments. And then you have automation in place to catch those bugs before they hit your prod environment. So you have all that in place with a SaaS vendor, that to build on all that infrastructure, all that capability, in a traditional sense would be significantly higher overall cost. That also lends itself with the speed and innovation. We can pull together new products and capabilities in days or weeks, as opposed to years, when we're able to roll out, again, small changes over time, learn a little bit as we go, as seen with other traditional software, as soon as we had the requirements built, those requirements became outdated in the market. So there's a lot of missing that, where this way we can roll out the small changes, small components, small changes, pivot here and there, and we can experiment and get closer and closer to what the needs of the customer are much better. And this also allows for lower barriers of entry. So no need to just, okay, I got to build and I got to build this big infrastructure. I got to bring in all these resources. Instead, it could be as simple as I really like how Salesforce works, where you just log in, set a trial license, and you're up and going with Salesforce in like a couple minutes. And instead, we can be more like that, where a lot of our software, SaaS software, can be up and running in like a few hours, and then connect things into their business systems in a few days, and they're starting to see the benefit, and then can use them, and then also shutting them down is not as big a burden if it's like, this is not really for us, and the customer needs to make a pivot, but we can support that better through this. Okay, move forward. And so, yeah, one of the barriers where that kind of makes SaaS difficult is the way that these things are funded, as a capital expense, and that even though we are seeing some movement in that direction under term licensing, um, but really it's how we kind of fund our teams and staff them up. It's really helpful if we can hang our hat on annual recurring revenue. So as the annual recurring revenue on the subscription fees, we can fund and size our teams accordingly and have better understanding of where should we invest, where do we divest because they're not as not as much value there. As opposed to kind of, we can tease things apart into term licensing, where there's a license component, hosting and maintenance, but then there's mostly, okay, it's large upfront revenue, and then it gets smaller, so it kind of gives a perception maybe this team isn't as needed, and then large upfront and smaller. So it really is a lot more beneficial with how we kind of fund and staff our teams, by being able to see that recurring revenue over time. And with the current requirements around software need to be in capital expense, and that's how they fund these projects, that definitely is much more difficult, and we have to be creative in how we support that. Make it look as close to on-prem as possible, even though it's really hosted, and then in order to get the accounting rules around that, it has to be on-premable. So again, we're back to the hosting and on-prem solution. You don't get the benefits of cloud native software. So those are the areas where we use some regulatory changes can help them fund and make it easier for us to offer SaaS software, and make it easier and less expensive for utilities to onboard the SaaS software as well. Next slide. Yeah, and so like this is a growing part of our portfolio. So when you get into things on the top, what we call outcomes, where we're doing distributed energy management or handling EVs, really being able to quickly pivot and make fast changes over time with each individual customer is kind of paramount. And that's where and getting these solutions to market quickly and get them deployed quickly, and keeping the infrastructure and the cost of entry low for these solutions really becomes key. And that's where SaaS, I think, has a lot of benefit for that. And this is more and more we're seeing even a lot of our competitors going more this direction as well. Offering more of these software as a service type offerings. And you just can't to put that whole, especially when you start adding things like artificial intelligence and big data analytics and edge compute, and bringing all that together. Even though it seems like, okay, software's still really expensive, why isn't it cheap all of a sudden because of SaaS? These solutions get even more expensive and more cost prohibitive if you need to put them in a traditional kind of on-prem capital environment. So if we can, the more we can take advantage of things like cloud computing, flexible compute, containerization, automation around deployment and things like A/B testing, feature flagging. That's where we can provide the most benefit at the lowest cost, possible to our customers. And move forward. I think that's the last slide. Oh, looking forward. So trends that we're definitely seeing. So I mentioned it before, but definitely mission critical software is kind of moving more to a SaaS or hybrid SaaS environment, and we do have to handle the security aspects around that as IT and OT start to blend together a bit. But we definitely cloud our cloud environments are FedRAMP approved, and we do make sure we have auditing and adequate auditing and security reviews and and to handle to make that NERC SIP compliant security intercloud compute. But we are seeing is more and more in order to meet the demand and the needs of our customers around DERMS and advanced analytics and real-time command and processing. There's more and more SaaS is more what's available for that. Obviously, the thing that I was finding interesting is that the largest security company in the world, or in terms of how many top security folks they hire, is Microsoft Azure. So the cloud companies are getting more and more where they really need to have probably the strongest security. I'm not just talking one of them, all of them as high as possible, and we build our own security layer within those environments, to make them to really handle the security requirements for those customers. And then adopting AI, like I mentioned, it's just those are cloud components, capabilities, and it really gets it's prohibitive, to bring that truly on-prem without some hybrid cloud implementation. That's it. Move on to the next one. Yep. Thank you.
Great, thank you. I think those are both excellent presentations. I have a lot of questions. I do also want to invite folks to enter their own questions into the Q&A box that's located at the bottom of your screen, and we'll try to get to some of those as well. I think the first one, you both talked about the benefits of this flowing to different parts of the utility, to the operating side, to the transmission and distribution side, and obviously capital. So I would be interested in your thoughts on how we can think about how regulators should be thinking about rate recovery. Like, how do we approach the problem of figuring out how do we allocate these expenses across the various buckets that we have?
Is there someone you want to go first?
I would kick you either one to start. Feel free, go ahead.
Okay, so I think that one way to maybe start looking at it is almost yeah, actually, we can look at the next slide. Could be helpful. Robert, if you want to pull it up. I think one way to start looking at it could be, well, okay, what are the components of a SaaS fee, right? What used to be parts that could be capitalized kind of as a basis here. It's not, as I was saying before, like totally apples to apples, because a lot of times your perpetual license fee may only include kind of the basic initial product, and it doesn't really account for new things and new investment, new features, capabilities over time. Although what we've been doing more is actually maybe trying to roll in those things into more of the maintenance concept, is as long as you're paying for maintenance, you're entitled to all new versions that we release, unless it's some specific custom one-off, right? That only, right, more of a services engagement. But anything that goes into the product, into the code, is available to our customers as part of maintenance. So if license and maintenance is something that used to be something that could be considered CapEx, it's still possible to look at what that would have been compared to the SaaS fee and maybe do some kind of a, prorating or calculation there and say, okay, well, that part is allowed to be counted as CapEx still, or something like that. That would be one suggestion of just how to start thinking about it. And I know there's already been a lot of progress kind of in this area of supporting utilities and buying SaaS as well. Because the way we've been trying to help customers get around it is, as Andrew was saying too, is we'll just split out the maintenance and the license and say, all right, here's the hosting, right? That's clearly O&M, right? Here's the license and maintenance. Sometimes we'll either put it all up front or, do some kind of extended contract to allow them to make a commitment. But, what's bad about that is they're still making that commitment then. So it's still harder to try a product, right? Because with that commitment comes the commitment. They can't just try it and say, it's not for us. We want to go a different direction.
Yeah, I think supporting the term licensing and also the rules around what's allowed, considered like a term, because right now I think the rules are mostly, if whether it's term or perpetual, it has to be effectively the on-prem model. It's just where is it being operated, and I think if there can be we can think of different ways to unwind, like if it's a term license, but it applies to software that's more not something that would be easily moved into a customer's private data center. That I think that would loosen up some of the requirements we have around it.
Yeah, I'm going to take this answer in a completely different direction because I think Andrew and Mimi very well articulated the capitalization, like, accounting treatment side of this far better than I could, and think about the question of alignment of costs and benefits, like who is receiving benefits from a lot of these investments and platforms, and are they the same ratepayers as who's incurring the cost of them? So not whether that's, a capital expense or an O&M, but just like pure beneficiary versus who's bearing the cost. And a lot of times, so this is more of a, I guess, challenge than having an answer ready to go, but specifically for sort of customer and billing software, a lot of the benefits do flow through to functionalities and cost centers at the utility that aren't purely billing or customer related. I'm thinking in particular, many of our clients, deregulated clients in Europe, have licensed our DERMS software with our customer software, and they work with them together. And so they're seeing the integrated benefits of having a DERMS speak to a CIS and a billing system really naturally flows through to things like increased customer adoption, lower customer attrition, higher uptake in demand response programs. And a lot of those benefits are power supply and sort of capacity benefits. And if we think about bringing that model here in the US, then that really becomes a challenge. Okay, a billing system that's paid for through base distribution rates, that's delivering sort of like core, power procurement and supply, that's a different misalignment, especially if you're talking about, the utility having competitors, and having like other suppliers that they're competing against. And so I think at a minimum, because there's not a clear answer on those questions, that's like quite advanced for the state of billing in the US right now. At a minimum, the thing to do to help answer that question is to be really clear with some of these investments, what the outcomes of the customer IT are. So it's really easy to think, okay, it's a billing software. The outcome is that I can run a billing operation, but that's a very simplistic lens to take with it. And if we're talking about making room for some advanced vendors to come in who are offering, much more nuanced functionality, like a pre-integration with a DERMS, or like a proven track record of being able to do, customized and tailored marketing or customized enrollment pathways, all of those features need to be articulated beyond just, it's a billing tool. So leaning into outcomes and then connecting the dot between outcome and cost center is sort of the natural next step.
And I think Emma brings up a really good point too, that I don't think it's totally off topic, but it's the fact that the lines are blurring between the different organizations in the utility. So, like she was saying, if you have, like, even for us, if we have software stood up that integrates with the CIS, for example, well, I've got a DERMS and a grid management tool that can use that same data, that same integration, and those same, across the utility. So I think we're seeing kind of more and more of where these lines are getting blurred, where grid management or grid operations or utility operations can take advantage of things that the maybe the customer service and billing parts of the utility also need as well. And so the more we can kind of bring all that together, the more efficient the software costs can be in terms of who's benefiting from, like, similar tools.
To that point, if I could add one more thing, I think another challenge in all of this and fitting the costs and the benefits together is that oftentimes some of the more grid edge software is being procured in programmatic filings, right? Like maybe there's a VPP filing, or maybe there's, an energy efficiency program, and the accounting of costs and benefits for those types of investments happens independently of the full O&M accounting that happens through a base rate case. And so if there are benefits of one software type in a different cost center or vice versa, those don't naturally flow through it concurrently if those two filings aren't happening together, right? Like if there's a FTE reduction that comes indirectly through the grid edge management software, if that's not being captured in sort of the base rate case, that accounting hasn't kept up with the true flow of costs and benefits. It's another challenge of just the way the utilities are procuring this and aligning sort of the policy regulatory pathway with the actual sort of investment and rate making pathway.
So a couple of questions which I'm seeing in my mind is related, but they're not really that tightly. But the first is, when it seems like whenever we are asking the utilities to do something, to make a change that requires some sort of change in their software, we get the response that this is going to cost millions of dollars and take a long, long time, right? It's like no change can be made in less than 18 months. So I guess the first question is, I assume that companies like yours can sort of help with that. I'd be interested to get your perspective on, can we effectively either reduce costs or speed up time for rolling out of things like time of use rates and other changes we may need to make to the system. And then secondly, are you finding utility resistance related to their concerns about having real tight control over their systems and the software that they're using? And Emily, you want to kick this one off first?
Sure. The answer is yes. That is the help is the aim of entering the U.S. market, having brought this system to market in primarily Europe and Asia right now. The challenge and the resistance that we're seeing is less about the control, and I think more so foundational, not necessarily having the full accounting of what the cost of maintaining the legacy architecture is and the legacy system is for the alternative providers to come and compete against. So an example that we constantly encounter in communications with and engagements with US utilities is if we say, we can do the change faster, which results in lower cost and less of that portion of total cost being borne by the utility, instead the vendor bearing it. There's a little bit of an eyes glazed over effect because it's not always, I think, clear to the people that we're speaking to at the utility what the total price tag has been of these incremental upgrades over time, especially for a billing system where those upgrades might literally be incurred every 6 months, right? They're not happening through one-off filing, so there's not a really clear record that there's one account that the money comes in and out of, right? It's hard, and so when we're talking about a completely new commercial model, I think that's where the biggest paradigm shift that we sense is. It's not in so much the control. To be frank, when it comes particularly to rate design and billing, I think a lot of the utilities we speak to understand the pain point very well and understand that they might not be in the position to be keeping up as well. And when we have those conversations, we see a lot of excitement on people's faces when we say we work with so many other clients who are implementing similar types of rate design innovation as what you're interested in. And if we have the responsibility to code that up, obviously you tell us the rate, but we're responsible for implementing it. We've gone through that with other clients. We can bring that expertise and say, oh, you might want to consider, this format of billing determinant versus that, or this, feature versus that. I think there's genuine excitement for that. So less of the control, more of just the misalignment of some of the sort of that cost comparative baseline.
I can speak a bit to some of the costs we're seeing, right, with adopting either new software or even just doing upgrades, because my team handles a lot of the classic data collection network management software. Nobody wants that to break. It's really bad if there's a large problem and you can't read your meters, or something is messed up on that front. So what we've seen is I'd say maybe it's the control, but it's really the risk aversion. Like, we can't mess up. And so there's so much rigor and process around testing and testing all the components together. And so what we've heard sometimes is if we say, look, we want to push out an update, right? We've got some changes, you know, you upgraded last year. It'd be really good if you upgraded again this year so you can get these things that we've added. It's just a huge cost, right? We will hear it's $1 million to do an upgrade because we got to test it along with everything else. And then if you change, you know, a single line of code during the 8 months of testing, we have to retest everything again. And so I think that that's really a risk, right? It's fear of something breaking. But I will say that sometimes that leads to, I would say, you know, adverse outcomes or actions that actually don't help with mitigating risk because, you know, certain things, if we need to do a fix that's urgent, we may actually get asked to do like a hot fix, right? Instead of sort of, hey, here's an actual patch release with more bug fixes in it that's actually better for everyone, but there are more changes in that patch release. So it's better to just have a hot fix that no other customer has, which is to me a more risky way to do it, but because it's a smaller change, it's more palatable. So I think there is this, you know, for certain processes at the utilities, because of the, you know, risk averse nature of the business itself, I think it does make it hard. But what I will say is, you know, as more of these products in the ecosystem, in the utility back office become more flexible and are doing more of the CI/CD, right, type of process, I think we're going to see a lot lower barrier for trying a new product. I think right now, I mean, years ago when I was working on trying to help some of our utility customers try new startup products, right, we were trying to do kind of a help basically pass meter data on behalf of the utility to a startup because it was such a big integration project for them to do it internally. And a lot of it was just kind of this process of like, we just have so many processes and so many tests that we have to do. And so, you know, I'm not saying testing is bad, absolutely not. But if we can get more automated and better, and if the products themselves are kind of less clunky and expensive to test, I think that would be really helpful. And that'll, you know, that's changing as we speak, but it's kind of a slow long-term change in the evolution of all of these pieces of software.
Yeah, and I mean, the only thing I would add is I think there's the risk aversion. There's also, we run a lot where every utility implementation system is unique. And so the more we can take advantage of standardization and, you know, I think that will alleviate a lot of their concerns around quality, right? Because if I can automate all the testing and I can automate that ahead of time and handle even the integration testing through automation, right? That'll limit that. But if every single customer is extremely unique and different, then that becomes difficult. And then you end up, okay, now manually test it all. And that's where I think you get the big, oh, any change is going to take $1 million and 100 people because it's all going to be manually done. I can't take advantage of any automation or any streamlined, you know, processes around that. You know, and again, I guess they're cash register, right? Especially with billing stuff. So there's, yeah, it totally makes sense. There'd be some risk aversion there too.
Great. I wanted to get to an audience question. Also, it kind of pairs a little bit with the question that I had. The question is, can you highlight applications that can be deployed quickly and have a significant impact on the electric sector? And I guess I would just add to that, you know, building on that, you know, how do you see this helping to improve the flexibility of the system and how we manage it? So what are some short-term things we might be able to do sort of to quickly deploy to benefit, and then sort of like the longer term, what can this do for us?
I'm happy to jump in that the unfortunate answer with a billing system is it's hard to deploy quickly and it's hard to deploy in chunks. I'm not aware of any sort of pilot of billing technology that's typically a uniform, an enterprise level investment. However, we are seeing some interest, and so this is more of a early stage, but interest in answering questions through a pilot format of what advanced billing infrastructure can do and peeling off a core set of cohort customers to test that on. That is really useful in places where there's a very clear forecast sort of demand for billing changes or rate changes, someplace where it's known, it's on the horizon, what needs to happen. And that could be, you could create sort of a test environment to say under one technology versus another, what are the differential outcomes towards that, implementing that rate design innovation. And that's not always easy in certain utility environments or regulatory environments. But as hard as it is to deploy billing systems quickly, they are everything, I think, as it relates to flexibility and running the grid efficiently. It really comes down to the point I made earlier that pricing is the primary tool we have to really effectively transact supply and demand. And I think we think about pricing a lot just from the demand side, like what is a customer going to pay and how does the price communicate when something's expensive versus not, and what the marginal cost to the system is. But pricing is also the primary tool to communicate what a generator and what supply should be doing, right? If pricing is really high, the supply wants to make it onto the grid. If pricing is really low, the inverse happens. And so making sure that there's an ability to sort of match the innovation that's happening in market settlement with the way that we're actually sending prices is really important. And right now, so much DER and assets are being integrated to the grid through retail funded programs. And retail rate design is about as sort of clunky and sort of uniform as it gets. And so thinking about peeling off or sort of getting further and further down the sort of dynamic rate on retail, or the dynamic road on retail rates is really, I think, the future we're excited about and where the billing system is so critical.
Yeah, I think for us, the ones I was thinking of is our back office analytics for AMI operations and grid operations. We have some product called Operations Optimizer that as long as it's with our standard, like our head ends or say things we have standard interfaces to, we can get that up and deploy it in like a couple hours and get it configured and up and running and start running analytics in a few days, with our services team. So these are fast things we can get up and going. And then as the data comes in, right, we have data scientists or analysts that can also then spin up in a couple days or a week, depending on the complexity, a new use case that can then be deployed and in line outside the release cycle of the software with low risk to provide new benefits. So that's where I see, again, I think the big key is the standardization piece. If I have to do a completely custom thing, that's where I think these projects really start to drag out, where we got to define it, and work it in. But if it's with a standard interface, and we have the standard interfaces in place, and the data exchanges are known, we have software that can deploy in like I said, in a couple hours and get it working and providing value in a few days.
Yeah, that's the one I had in mind. Operations Optimizer is, as long as it's on sort of our AMI network, it's pretty much pre-integrated with the meter reads that are coming out. And you can knock out a whole bunch of stuff up front, right? Like looking for non-technical loss. I mean, you can save a lot of money just doing that alone.
Reducing
and
rolls and through,
yeah,
making sure the billing is coming through. Yeah, all that for sure.
Right. But that's actually the product I had in mind when I was saying, certain products may benefit a whole bunch of different teams, right? And so in some ways it can actually be hard to pull the trigger to buy it because there's maybe a little or a lot of benefit, but there are 8 different organizations that get it.
Yeah, and I think the other thing that I think Emma mentioned earlier is good is not capturing the operational aspects. So a lot of time we'll run into where, well, we will build it ourselves, or we'll get in a system integrator and build it ourselves. And okay, that can be done, right? But then it's, well, how do you maintain the solution for the next 15 years or 10 years and operate it, and all the things around that aren't captured. So it's really hard to do a good apples to apples comparison in terms of cost or business case, because there's, all those other aspects that are, not even accounted for, where I think, a SaaS solution out of the box, well, that's where it'll save you mostly, is around your, overall, over the long term, as opposed to maybe, and as well as upfront, but maybe not as much as the upfront costs.
So you touched a little bit in your presentations on, cybersecurity and sort of data privacy concerns. What if you could just shine light on how is regulators need to be thinking about this? Are there particular risks of moving to these sort of types of technologies, or or is there some other, or is it sort of just part of a larger cybersecurity sort of program that a utility would need to be able to maintain?
I think it's part of the larger cybersecurity model they need to maintain. I think there's a lot of consolation on this, where I'm seeing common patterns, like, higher secure zones, pull from lower secure zones, how that integration goes with cloud solutions. And then also recognizing these cloud vendors, are investing heavily in security on their own right. So making sure that they're, using obviously approved, whatever vendors using approved cloud providers that do have a huge stake in their cybersecurity posture. And then also that the vendor is built layering their own security product, security implementation on top of it, because you have to use both. But a lot of that seems to be pretty well covered, and there is more openness, I think, to that within a common set of requirements, especially when you get IT versus OT. And so keeping that consistent, where people are, whether it's the Purdue model or they're following, other, standards. I mean, that's where we really get into, okay, what standard are you trying to follow? What protocol, so we can respond to that, as opposed to, again, everyone's a snowflake, everything's different. The more cookie cutter we can make things, the easier and less expensive we can respond.
Yeah, I less of a view on the security side, other than noting, what was already said about using sort of native security tools of whatever cloud hosting are as a vendor we use, but more towards the privacy piece of this. So not wanting to speak to what the standards for privacy should be, or like what the role of the commission should be in sort of determining or implementing that, but really raising that from there's also the question of value when it comes to privacy. So utilities are sort of being asked, whether they're implementing it or not, they're being asked to sort of retain more and more information about their customers. I like to use the example of sort of income information, right? Where there's many jurisdictions pursuing tip of the spear items like income-based rates or income qualification for different products and services. And that's a good example where the utility is collecting that information, that they may or may not be retaining that information, tax returns, tax records, like very critical information that's not so much part of the typical course of business. And right now, oftentimes those weird sort of edge case data sets live in very different places. They're hosted like in different places with different software. And I think that's a big privacy concern, that it's sort of disparately managed. And then the value piece of that is if all that information lives in different places and is stored in different ways and is not useful to a common set of business practices, then you're incurring risk of storing that information and not getting the commensurate benefit of having it be useful across the board to the utilities operation. So continuing with that example of income information, if there is a program or a piece of software that's set up to retain that information and perform a single business process, like an eligibility check, to make sure a customer could qualify for an arrearage program or an offering, if that's custom built for that one business process, and then a new business process comes to light where it's like, oh, we could really do something great if we had that income information. If that is not easily accessible and easily usable, then you're really minimizing the value of what was a sort of risky upfront endeavor to collect in the first place. So we have to think about creating like sort of redundancy and accessibility of the information, so that it's not just privacy, build a wall up and don't worry about it, but once you build the wall, optimize how it's being used internally.
Great. I think we are unfortunately running out of time. I just want to thank all of our panelists. I think this was an excellent conversation, and certainly it just raises more and more questions. I'll have an opportunity to talk with all of you later. I think this is just such a timely conversation. I know in Maine, we're sort of really thinking about how do we get a lot more sort of out of the systems, the AMI systems, and how do we make sure that we have data and information that can be accessed by other stakeholders who are integrating with the grid. So this was very timely, very helpful. I really appreciate you taking the time to do it. And I certainly thank all of our participants who joined us today. And a thank you to NARUC and CPI for putting this together.
Thank you.
Thank you for having us.
It's great to participate.
Yeah, thank you very much. Take care.